When I'm building a year-long context for math, there are some things we need to consider just because of the nature of the discipline. Math fundamentally is an abstract idea. It is technically all theoretical. But in that sense, we also describe it as incredibly concrete, in that we say concepts in mathematics build upon one another. So it's not the kind of thing where a math teacher would say, oh, we're doing all the standards all the time. In fact, it's just the opposite. We feel that things in concrete ways, the domains, if you will, or the discipline chunks out. I'm doing geometry, I'm doing measurement, I'm doing operations and algebraic thinking. So because of that, we need to think about these standards, whatever standards we're aligning to, and read them very carefully. Many standards today have multiple skills in each one, and they're pretty precise in their verb. So they might say that we need to recognize a concept, that we need to solve problems with them, we need to explain a concept. So one of the first things we do with sets of standards, math standards, unlike literacy where we would go into the writing first, what we do here is we try and sort the standards into elements that are developing fluency, elements that are developing deep understanding, and elements that are developing application. So having your faculty kind of walk through and read those standards with those three lenses allows them to create bundles. It makes them say, oh, things that are going after fluency, perhaps, I can do pretty early. Okay? And there's certain things I would connect that with. Things that are about deep understanding, though, where a child would actually have to explain things and they would have to describe the impacts of things. I need time to develop that. So just because the child could solve a problem with it doesn't mean that they could explain in a rich way what that solution meant or evaluate if that solution was the best way to go about it. In the same way, application, where the child is actually a mathematician, where they are recognizing mathematics in their environment, or they are recognizing choices that they can make about strategies to use. That level is something that we want to be strategic about. I wouldn't want to put all my application standards in the same bundle, for example. And in some cases, an application standard for one domain might pull different standards from other domains as a way to actually reach that application, showing areas of integration within the math standards that would be stronger than just saying, here go all the fraction standards, here are all the geometry standards. So this is one of the first steps. We do that, and then we can actually create our bundles. Again, September, October, November, December. Make sure I go into some rich areas in January and February, March, April, and May, June. The mathematical practices or any kind of big picture why that your standards might have with math, because regardless of the version of the standards you're using, there's going to be something that speaks to that. You're going to want to make sure that you reflect back on those. And again, not everywhere they happen, but where you could connect it to a bundle and get evidence of the learner being metacognitively aware that that's how they're thinking, which is different from, oh, we did an activity and they actually used models. Okay? Yes, the students experienced models, they used models. The difference here is I'm saying modeling, and I want the students to say, modeling was very helpful to me in helping me solve this problem, and here's why, and here's how. That level of being aware that they were thinking through models in order to solve problems shows us that we're actually developing the mathematical lens in a child's brain. This becomes so meaningful when we talk about retention. When we talk about, oh, I covered fractions in 4th grade, I covered fractions in 5th grade, I covered fractions in 6th grade, I have unit tests where they passed. Why is it they go up to 9th grade and they still don't understand fractions? I'm going to go back to those year-long contexts and I'm going to say, where did we actually have the children show and talk and think through why fractions and models of fractions and persevering in solving problems with fractions in reflections in a journal, like a math journal, for example? Where do we have that? because that would be the key to developing that retention we're looking for. And that ultimately saves 3 to 6 weeks of instructional time. So the year-long context for the math department is really going to focus on the development of that fluency, that deep understanding, that application, and ultimately the lens of mathematical thinking through the why. And for us, math, that's the answers to the essential questions. So your year-long context is going to be the framework for those pieces.